Hello, everybody. I'm David Hoover here from Google, and I'm going to be talking about Kokoro, which is Jenkins inside Google. So, who are we? We're about 10 people these days, small team. We've got a mixture of software engineers, some system administrators, and some management cracking the whip when we go off track. And what do? We are a build and sign service for non-standard Google projects. If you look on the internet, you can find all kinds of great slide decks talking about some of the build infrastructure we have. If you're doing sort of a core web service that's going to run on our servers, there's a lot of really great infrastructure. It happens, it goes out to build farms, it's great. But then we have things that don't fit that mold. Things like Windows programs, Mac OS, iOS, sort of like Linux client things. They don't fit that mold, so we handle them. We were tasked with replacing an aging system. There was another thing that used a proprietary third-party program to do very similar stuff. It was showing its age. We had to manually maintain a fleet of machines, and we wanted to update it. And also, we wanted to replace all the ad hoc Jenkins use inside Google. There was some network crawling by security done at one point, and basically they found dozens of people who are basically running Jenkins under their desk for their own little project. And we would like to take that load from them. As everybody knows, it can be a little bit of a hassle to run your own Jenkins service. We just want to let developers develop instead of worrying about running that. And our big goals were to make sure the system was secure, that it's reliable, and that people could do self-service. We don't want to be in the business of helping everybody get their build set up and running. So we've been at this for about 2 years now. Last year, throughout 2015, we looked into how viable Jenkins was. We did some stress testing. We found some critical bottlenecks. And we presented with our findings last year. Got a link to the slides for that, or again, just go search for it. There's some interesting numbers. And near the end of the year, we started onboarding our first actual Windows customers. Then this year in 2016, we launched Linux support. We've launched Git and Gerrit integration rather than just integration with our own in-house revision control. And we are launching Mac OS support as I speak. That went live this week. So the big takeaway from last year's slides, we ran some stress tests. We saw that we should be able to do a single master with 500 build agents. We did 2,000 projects, and we did a simulated load of 500 builds per minute. Which is pretty excessive, and those were little no-op jobs, but everything handled it. So how are we looking a year later? We have one master. We currently have over 100 build agents. There's about 200 Windows projects and 200 Linux projects. We do about 1,500 builds per day, and there's about 250 active users. And then this week, we're launching Mac support. We're turning up upwards of 400 build agents for that. And looking at the other tool we're deprecating, we're expecting to bring in something like 750 projects, doing another 3,500 builds a day, which, if you add them up, we're talking about 500 build agents with 1,200 projects. That's not too far off from what we expected. Builds per day. This is starting late 2015 when we first started Windows support, and as you can see, it goes up and to the right. There's a little bump when we launched Linux support. The blue line is actual builds per day. Red line is the trailing 2-week average. So the peaks and valleys are the work week versus the weekend. So on average, we're seeing 800 builds a day. In reality, an actual work day is hitting 1,200 on this graph. Those looking at the numbers on the bottom see it's almost a month out of date. We're now hitting 1,500, 1,600 in a day. And so how did we do it? We reduced the load on the Jenkins master. We store the artifacts externally. That's not a giant surprise. There's a bunch of people here talking about that. The files get big. Serving that on the master is expensive. But not just size, the number of files. Last week, we actually had some excitement when one of our projects hit about 18 million files in their saved artifacts. And they had a default quota of about 20 million. So we had to help them out, raise some quota, clean some things up. Another thing we do is we store our logs externally. Most people stream that back to the master. The Jenkins UI actually serves up the logs. we pump them straight from our build agent to an external log service. And so the master itself doesn't see these potentially hundreds of megabytes of build log. It just has the URL to that external log store. And we plan to open source this work, maybe later this year, maybe early next year. It's in the works. We also directly install all of the jars on the agents in advance. We mentioned this in our slides last year, but at agent startup, when it connects to the master, normally it pulls over all the plugins, all the code to run. For our plugins, that added up, and it's over 500 megs. So each agent, when it connects to the master, would have had the master serve it half a gig. That gets very expensive very quickly when you have lots and lots of those doing it. And then we also pushed all of the work for continuous integration to an external service. Rather than the Jenkins master itself having a thread that's pulling all these different Git repositories, pulling our source repository, we run those as separate services. There's one for Piper, our internal revision control system. That can subscribe to a feed of submits. It's kind of like GitHub webhooks. And then we have another one that's pulling our internal Git repositories. And when they see there's new work to be done, they just fire off an RPC. Jenkins schedules the build. Everything runs from there. We also reduced the administrative workload. We don't want to do lots of configuration in the UI. That gets painful. People accidentally click the wrong button. So instead of sort of the classic way that people configure the master, tell it how to fire up a bunch of agents, we spawn them externally. And they phone into the master and automatically register when they connect. This is done over gRPC. It makes it very easy to scale the pool because we're just running jobs on our internal cloud. We can turn those up as needed, and they just show up. And that work is in the process of being open sourced also. We store all the project configurations in source control. That is not data stored on the master. That gives us the benefit also that when people make projects, they change things about them, it goes through the regular code review channels, you have 2 people looking at it, you've got full history of everything that happened. There's no wondering, wait, why is this build doing this now? You can go and figure out why, because it's got revision history. And similarly, you don't go to the UI in Jenkins to add a project. It just notices that the files showed up in source control. There's a magic directory. You put things there, they show up. And it always reads them directly from source control, so that is the definitive source of truth. And to make things reliable, we'd keep things simple. Agents are one agent to one executor. Many people will have these big, beefy machines that they run their agent on, and then say, well, this has 32 cores. I better be running 32 things on it. But that means if something goes wrong, it may take down 32 jobs. This is very simple. We're running in the cloud, so we can fire up lots of small jobs. Keeps things simple. We automated Jenkins master failover. We have spares that are sitting around warm, ready to take over if it fails, so that we have very quick failover in case of problems. And virtually none of our configuration is done through the UI. We have it in source control, so we can track all the changes. You don't have problems due to misclicks. I'm sure nobody in this room, and definitely I, have never clicked the wrong button and accidentally done something horrible. And then we added monitoring and alerting. We export a bunch of metrics, collect them, we watch trends, we have exciting dashboards with all the lines, and there's alerts that notice if some failing condition is triggering. If it realizes that all of the builds suddenly across the system are failing, that's probably that something's wrong. It alerts a human, we can look into it. And with this system, we've only had about an hour of unplanned downtime this year, which, not too shabby. So the agent design, I mentioned, one executor per agent. It's easy to schedule lots of small jobs in the cloud. It also means 2 jobs can't interact with each other. There's no hoping that job 1 doesn't reach across into the workspace of job 2. If something goes wrong and an executor crashes and burns, it just takes its job with it, not everything else on the machine. We also run all of our workload inside a sandboxed VM. That lets us restart the VM with a clean OS image after every single build. So builds are more reproducible. They're isolated from the network, so you can't do nefarious things. You're not at the mercy of external network connections working. And then we keep plenty of spares online. Stephen before was saying that you want to keep around, I think he said 30 to 40% utilization of your agent pool. I think we're hitting maybe that at times. And VM reboots take time, so we want to just make sure they're there so they're ready to go. And so the design for our Windows and Ubuntu slaves, there's a big container running in the cloud. It has the Jenkins agent, which is the process everybody's familiar with, running slave.jar. Jenkins talks to that. That then goes out to the source repository, gets the source code. That directly streams logs to this external log service rather than sending them back to the master. It also, at the end of the build, publishes artifacts out to the external store, again, bypassing the Jenkins master. And then, after it gets all this work, it puts it into this sandbox virtual machine, runs the job in there, pulls out the artifacts, publishes them, and then, as I mentioned, throws the VM away, starts up a fresh one. Mac OS is slightly different. We had a challenge. The Mac OS and iOS builds need to run on Apple hardware, and we do not have Macs in our production data centers. So how did we solve this? We put Macs in a different data center, and we pair Macs with Jenkins agents. So much like the VMs, there is a mapping. A build agent has a Mac to do work on, and after each build, we net boot the Mac, put a clean OS image on it, very much like rebooting a VM. We had to have a registry to do this, so in one data center, we've got a bunch of Macs. In the other data center, we've got a bunch of Jenkins agents. Mac comes online, it tells the registry, hey, I'm here, I'm ready to do work. And then agents come along saying, I would like a machine to do some work for me. The registry tells them, and then the Jenkins agent and this Mac just directly talk to each other. Gives us a picture that looks very familiar, if you remember the slide, like 2 or 3 slides back. It's just that now, instead of having a build VM running next to the Jenkins agent, it's an actual physical Mac over in some other machine cluster, and the little arrow between the two is a much slower network connection. Otherwise, the architecture is exactly the same. This also lets us do things like run agents, build agents in GCE or in device labs. So just like the agents, we can run our Jenkins agent on our cloud, and our customers can run a build machine in GCE or in some device lab. This lets them have completely custom build environments. If they need some really weird exotic operating system, if they've got some really huge workload, maybe they are somebody that really needs 200 gigs of memory to build or run their tests. We're not going to give them that by default, but they can spin up their GCE instances, pair them up, and we'll run on them. If you have a hardware lab with attached devices, we can do that. And we have some teams who want to really very much control the hardware so they know it's this machine. They can run performance benchmarks, get reproducibility with that. Project configuration. I mentioned we keep this in source. We had looked at some existing approaches back when we started this project. There was Literate, YAML, pipelines, DSL. Nothing quite did what we needed. In general, project and build configurations were tightly coupled. There wasn't necessarily the ability to easily share chunks of configurations. Plus, users could still go into the UI and change things. We wound up writing our own thing where we split the projects and the build configurations apart. The project config is always read at head from source control, and the build config is read at whatever revision you're building at. That way, you can have the project, but you can still build, update your project with modern things, but still build your thing from 3 months ago because you have some reason to do that. We read this config and generate all the build steps at runtime. And then, as I mentioned, project registration just happens automatically. You check in the files, something notices, sends an RPC to the master, your project shows up. And this also allows nested configurations. We sort of have a hierarchy of common bits, and eventually you get down to the leaf node that is your actual configured job. So as an example, we have a top-level common.config for a continuous integration build. It pulls in some code for some project and also some shared library. It'll send an email about build status to some team at google.com. And then there's a Windows config, which says, hey, I'm a Windows build. Here's the path to my actual build config files. Or here I'm an Ubuntu build. I run on those machines. Here are those files. And by the way, override the email address, send stuff to the specific team that cares about this. And then the actual build config, this is the one being read at the same revision you're building at, has pretty straightforward things. It says, here's my build script, only run for half an hour, and at the end collect all of the .exe files out of some directory. And what about pipelines? There's been a lot of talk about pipelines today. We're planning to generate pipelines based on our existing configs. One of the big things we're interested in is that should give us some durability across master restarts. And all in all, it's going to look very much like the declarative pipelines if people have been seeing the demos and talks about that. We're also investigating more general use of pipelines. Some of the other teams running Jenkins do have some big fancy builds that 1,000 lines of pipeline doing complicated stuff. We just have to be careful because pipelines run outside the sandbox. We need to make sure people can't do things they shouldn't do with that. Master failover. This is what I mentioned earlier. We have one active master running and a couple of warm standbys. While it's running, it's constantly sending its local data to a network store so that we have a persistent backup of that someplace, and a bunch of agents are just connected to it. But if something goes wrong, the big quake hits and California falls into the ocean, that master goes away. The agents realize they lost their connection. Unfortunately, today that means all the work they were doing is lost. But they're still online because they happen to be running in some other state where the quake didn't hurt them. The standbys, one of them realizes that somebody else needs to do the work. It comes online, grabs the latest state of the backup, and starts serving. The agents automatically reconnect to it. While there was downtime, they were just furiously going, hey, I want to connect to this master. I want to connect to this master. Where is it? Where is it? And when the one came online, they automatically reconnect to it. We did lose the in-flight builds, but they're up and ready to take new workloads. So what have our pain points been? The singleton master. It is a giant monolith. We can't run many of them and spread the load. If it fails, we have downtime. If we need to do an update, that causes downtime. In-flight builds are lost if the master goes away. Obviously, as I mentioned, if there's a failure, that happens. But it also means during a production push, if we want to push a new version of our software, that restarts the master, all the in-flight builds are lost. So we try and push updates during quiet times. If you remember back at the beginning, 1,500 builds a day, that's on average a build a minute. There are never quiet times. So we lose work. Agent management. Jenkins is not really geared for handling hundreds and hundreds of agents. You go to the page, there's a column everyone's familiar with on the left with the executors, and they're there, and you scroll, and then you scroll, and then you scroll, and then you scroll, and you're still halfway through it. If you need to do some sort of maintenance thing, take some particular set of them offline, there aren't great tools for doing that in bulk. We wrote some things to do that, but managing these giant agent pools is a little bit of a hassle. There's also not great affinity between a project and an agent. With hundreds of agents, you run a build, there's a very high chance it's going to be on some random agent that is not where it built before. So in practice, we very rarely see incremental syncs. Some of our projects have very large source trees. It would be really nice if we only got the 1K change that they made. But in practice, it lands someplace that didn't already have a copy of it. We do the full checkout. So pairing those up would be nice. And where do we go from here? We are onboarding macOS builds. As I mentioned, this just launched. Hopefully my team is still here. We've been watching, waiting for the phone to start blowing up if something goes wrong. Pipelines. We want to move to pipelines, get durability in case of master downtime. We can also start taking advantage of some of the parallelization that gives us. It also works very nicely. Blue Ocean gives us some great visualization on that. We're onboarding new teams. Our original mandate was turn down this old service, replace it with ours. We're almost done with that, so we've also been onboarding, as I said, all these random ad hoc Jenkins uses. We've got other teams that want to come on. They haven't necessarily been using Jenkins. They haven't necessarily had a great build process. We're taking them on. They need some new features. We're looking to better integrate with other systems. We have a bunch of acquisitions with their custom build stack. We need to talk to the things they need to talk to. We need to support the features they need. And custom build agents in GCE, some people have special needs. They have very special builds with exotic setups. we need to help support that. Blue Ocean, that's coming. We did a brief hackathon with a bunch of CloudBees folks. We got some great progress getting that hooked into our system, and that plus pipeline should be a great experience for us. And then we're just going to keep scaling. We're hitting about the numbers I mentioned that we were aiming for last year, and that line is just gonna keep growing up and to the right. So, questions? Do we have a diversity in our size of builders? What do you mean?
Different size, different proportions.
Currently, they are homogeneous within pools. We have all of our Mac build agents are on identical hardware, and the sizing and OS image for our Windows machine is the same. We've tried to get a single VM image that has the tool chain that everybody needs, is a size that works for everybody but is not so huge that we can't run lots of them. Going forward, we're going to be seeing more diversity. We're going to need to address that. So the question was, we're using it for building, or are we planning for testing? Many of these builds have tests built in, so that quote-unquote build step is actually build and test. We do have some projects that are, fetch this resource from someplace else, this pre-built binary from somewhere, and run tests on it. We are doing that. We're looking forward to potentially pipeline so that we can better, have the build and test as separate things, maybe run, fan that out onto multiple agents. But right now, it's just one monolithic step in the middle. If the master goes away, what is the time to bring up a new one? That failover is on the order of, I believe, a minute and a half, 2 minutes? Yeah, about that. We've been doing a little bit of work to hopefully reduce that. Some of the data we're restoring at the beginning is actually unneeded, so if we can cut that down, it'll speed things up. But we're hitting about a minute or two, which is not too terrible. Ideally, would be as close to 0 as possible. Oh yeah, so do we have plans to work on the fact that it is a singleton master? Yes. On Tuesday, there was a bunch of discussion about trying to get some of the storage for Jenkins itself off onto distributed systems. Once you sort of have that going, it gets much more viable to have some sort of decoupling, maybe have some of these view things as separate things, and you can start running a bunch of them because they just need to read a data store. And that would push Jenkins towards more of a microservices approach, which would let us scale, load balance. It would be great. We would like to do that. In the back, in the middle. We are offloading our work to a VM. Yes, the agent. So the agent and the VM are both just running on the same machine. It's really that we're pushing all of the work into a VM for the sake of sandboxing it. And also so that our Jenkins, the Jenkins agent, that task is always in a consistent environment. I know Java is theoretically write once, run everywhere. In practice, we know that doesn't quite work out. So it's nice that that code is always very consistent. It's running on our standard internal Linux image, and then we go out to this VM with whatever's needed for the build in particular. Why not run inside a Docker container? Our internal cloud stuff is dangerously similar to a Docker container. It's very much like that. Part of the reason for the VM itself is that we want to, again, keep it really isolated. We have this VM. People can do whatever they want in it. We're really confident that it's isolated in this. And so we like keeping this nice, tight sandbox environment. But the whole thing is sort of like Docker containers. So for continuous deployment, is there an overarching policy? No. Yes. Each individual project gets to do what they do. If we notice some project is doing something particularly heinous, if they're chewing up all of our build executors, we might do something about that. We have a couple projects that are, for instance, they're very large. Their builds take on the order of an hour or two to complete, and they want continuous builds on that. And they've got a very high rate of code check-ins. We don't let them just saturate our build pool with that. We do say you can only run one of these at a time. They miss some intermediary builds. But other than putting restrictions to keep them from basically denial of service stack on our service, other than that, people get to do what they do. Do we re-image the Mac Minis after every build? Yes, we net boot them. Why do we do that? Yes, it does add to the queuing time. Part of the reason we have so many is so that we have enough that the few minutes it takes to boot doesn't hurt us. We always have some spares up and running. But the big reason is we want to make sure that that machine is clean. We don't want Project A's build to have left the machine in some sort of funky state and then have that cause problems for Project B. You know, you're running on it, they could leave files around, do something weird. We want to make sure everybody has a known reproducible build state. The software needed for that build, yes, our OS image that we install on NetBoot has all of the things they need for that build. We, much like the VM images we're building and booting, you know, we try and bake in everything that everyone needs. So far, we've been able to scale that we have one size fits all. You know, that does mean we have several versions of Xcode installed on the Mac, and people need to choose which one to run with, but it's all just there. What is the overhead to reimage them? I don't honestly. Yeah, they're not. Yeah, so for my team, he knows more about the implementation details. They're not being really re-imaged. They're net booting. They're pulling the things they need over the network. So how long does it take for them to boot? It's a couple minutes, 4 or 5 minutes, and then they're online ready to do work. Yeah. John, is that one okay to answer, I think? Yeah. So yes, within the VM, we have it in a sandbox. It's locked down. They have sudo access. And that's, again, part of the reason we really want to just pull out and nuke the site from orbit, because it's the only way to be sure. So how do we deal with builds that need to pull down things during the build process itself? So I say they're sandboxed and completely isolated. We do poke some very specific holes on demand. So you know, if somebody does need to access an external resource during build time, they need to talk to us. We need to clear that, get this all done. You know, so it's very controlled. We poke the holes that people need. In general, we don't let anyone just talk to the internet. Yes, and so John, my boss there, pointing out that so while we have these secure ones in the sandbox, we are also planning sort of with the GCE slaves there. As I was mentioning, teams, you know, run their own agent in the cloud, give us that machine, we send workloads to it, and so then that is potentially out there. It can do more things. We're going to put restrictions on what they can get into it in the first place, but that will be much more open if they need it. So for instance, some of our projects that really are working on pure open source, it's okay if they need to do that because it's all out there already. So the question is, do we see delays copying artifacts out of the VM back to the agent? Not much. It's on the same machine. We do a lot with either local SSDs or just keeping it in RAMFS. So it's, you know, there's some overhead because technically you're doing network connections between these two processes on the same machine, but largely it's memory-to-memory transfer inside a machine. And then you squirt it to the actual artifact store. And that's the overwhelming factor, is actually getting it off to something else across the network. At a high level, what is the trick to getting the hot swap of master to work? First, I would say hot swap is slightly generous. The standbys, we have internally some stuff for doing master election so that you can bring up a bunch of things, they coordinate, and so one of them gets mastership. And so we do that, we bring up a bunch, the system works, one of them gets picked to do the actual work, it's doing the actual work. It goes away, this master election thing realizes that, hey, the one that was in control disappeared for some reason, the remaining ones pick out another. And then like the slide had said, you know, the one that's actually doing work is constantly sending stuff to the network. So when one of these new ones gets turned on, you know, whenever any of these come online, basically, it says, give me the last state of stuff according to the network, boots up, and then it's serving. So talking about domain names and how to redirect that, yes, there's, you know, it's sort of like going through a load balancer that you go to this named address, and that understands how to funnel it to the one that's actually working. Same as you would do, you know, anything. If you hit google.com, we're all just typing that at the bar, it gets to us, and then we say, okay, we're going to go feed you over to this one of the things that's serving that web page. we're doing the exact same thing. The agents are saying, hey, give me the Kokoro master, I want to talk to it, and the load balancer directs the traffic as needed. How often has our master gone down and why? Not very frequently. We've had some issues where external services have gone away. You know, as I mentioned, we're reading our configs directly from source control, and so if they have a network hiccup, you know, that service goes offline for a little bit, that really causes problems for us because we're actively trying to read from it. Luckily, that doesn't happen very frequently because at the scale of Google, there's a lot of people hammering that. So we've got a bunch of really great people working to make sure that that's always up. But we've had a hiccup where that went away and that caused all kinds of exciting problems. Similarly, you know, something goes wrong, someone with a backhoe takes out a fiber link and suddenly these two data centers aren't talking to each other nicely. That could happen. I'm trying to think in practice what we've had. You know, things break. Luckily, they haven't much. Yeah, PCR. There's potentially there's just planned downtime that, you know, they need to do maintenance in some data center, but you know, they warn us in advance so that we can make sure that we're not running in there when it happens. In practice, maybe we don't actually get to it in time and it dies and fails over. Ideally, we do that more gracefully in advance, but yeah. In practice, it's been pretty solid. Yes? How do we manage whitelisting libraries? In what sense? Build dependencies. So again, we provide the VM image. So if there is some third-party library people need to depend on, they come to us, we vet that. Similarly, you know, it's up to the project. If it's checked into source control, you know, we have mechanisms inside Google for saying, here is third-party libraries. They can fetch those. And inside Google, there's just a whole process for dealing with and vetting that stuff. But largely, as far as we're concerned, that's up to the team and what they're doing. That's just part of their source. So the question is, do developers get some signature on it before they try and check it in? There is a whole process for pulling in new versions of external things. I probably shouldn't speak to it more than that, other than, yes, we take it very seriously. Okay, well then, thank you, everybody.